Hi, this is Carl Fossen with NetSPI, here to give you a quick rundown on a recently remediated vulnerability that we identified in Azure Function Apps. So if you're not familiar with Azure Function Apps, it's a lightweight API hosting service within Azure that is really convenient for throwing together very quick APIs that you want to use within your Azure environments. So as part of this PaaS service, you do have portal access to edit files that support these function apps and the APIs. And we can see a couple of different menus here that are available within the Azure portal. What we identified was a vulnerability in the VFS or virtual file system API that hosts these files and serves them up to the browser. So you can see in the URL here that there is a relative path equals 0 parameter. Now, by default, in the URLs that are used by the APIs in the portal, that relative path is set to 1, and it's a relatively restricted file path that you can gain access to. And prior to remediation, these APIs were available to anyone with the reader role within a subscription. So anybody that had reader rights on the app itself could view any of these files. If we set this relative path to 0, it actually allows us to enumerate files on the file system of the container supporting the APIs. So if we modify the VFS path here, we could browse to different things like the proc folder within the Linux containers. And furthermore, into those proc folder subfolders, we can look at individual process IDs. Anybody that's familiar with the proc file system knows that there's a /environ directory or file, whatever you want to call it, within the proc file system to gain access to the environmental variables that are attached to that specific process ID or PID. So what we identified was a directory traversal of sorts that allowed us to get access to sensitive environmental variables that were attached to processes in the Linux containers. There were similar kind of issues with related Windows containers for these same APIs, but not as impactful. With these environmental variables, we're actually able to get access to a SAS token URL that's attached to a storage account that is used to hand over the context for the container when the container spins up to run the function app. That context actually contains sensitive information, including the keys used to authorize access to the function app. And those keys can also be used to overwrite the function app to gain code execution in the environment. So we see in the environmental variables here, we have container encryption key as well as that SAS URI. And combining those two things, we have the encrypted content that was hosted on that SAS URI, the encryption key, we decrypt all of that. We get access to source code zip files, the secrets for the actual function itself with access to that master secret. You are actually able to overwrite the function app code with a put request, actually gain code execution in that Linux container, which can be really impactful. It effectively elevates your reader role that has access to these files to closer to a contributor role, being able to actually modify things at this point. Finally, if the function app utilizes Azure Active Directory for authentication, those app registration credentials are actually exposed within the SAS context files that we're able to decrypt, or the configurations that we're able to decrypt. So that's a potential pivot point at that point as well to gain access from a reader role to then whatever app registration is tied to that container. So this has since been remediated by Microsoft, and the fix was in a few weeks ago. But if you want more details on the actual vulnerability itself, go check out the NetSPI blog. Thanks.